Good morning. We are here on a Saturday morning just to answer some questions and give support for the midterm in statistics. And before we get started, just wanted to make mention, a few people have asked, like, what are the expectations for turning in your work on the midterm? So this is really just for me to be able to see that you actually did the work yourself. Hopefully it's your handwriting. Um, and if you do any work in Desmos, if you want to save that, it's a great way because let's say a student really believes they should have gotten a problem counted as correct. If you have turned in the evidence, I'm happy to go back and look at it. I don't go back and look at every single question to give partial credit in Alex because you're already getting the benefit of not having the lockdown browser. So that's kind of your benefit there. But like I said, if you turn in your work and then you have questions that you want, want me to address, if you send me an email regarding those, I'm happy to do that. So I'm not expecting you to show work on every single thing because some of the questions don't require a lot of mathematical writing. So the first question that I'm addressing today is chapter 5.3. Is there a particular one? So let's see. The mean and standard deviation, or I'm guessing, let's start with the binomial problems basic. And then we'll go on. Oh, the other thing, I'm not sure if everybody's reading all of my announcements, which you should, because that's really where I kind of give you updates every week. And I put a copy of the new formula packet out there that may be of interest to all. Where did I put it? Here it is. Okay, so this formula packet, it might be helpful just to pull it up while you're taking the midterm. Or I'd say print it out because you're going to be using this for the final for sure. So on the discrete probability, I've given the formulas, and then I kind of recreated this table, added to it with the binomial distribution directions for Desmos, which is easier. In the forum for chapter 5, I had shown 2 videos, one using Alex and one using Desmos, and I think Desmos is easier. The reason that the Alex was really even there was because before, when I had the lockdown browser, you were unable to even go to Desmos. And then just this last semester, I decided to remove the lockdown browser, which opens up the availability to use Desmos, which is much easier. So I have both videos. So using these words here will kind of tell you what symbols you're thinking of, and then being able to use the binomial distribution. Now, from my notes with the binomial distribution in Desmos, it's changed a little bit. They've actually improved it in Desmos to where it's a little bit more automated, but you have to know what you're looking for. So let's go here. Oh, where did it go? Okay, so it says a TV executive is interested in the popularity of a particular streaming TV show. She has been told that a whopping 68% of American households would be interested in tuning into a new network version of the show. If this is correct, what is the probability that all 6 of the households in her city being monitored by the TV industry would tune into the new show? Assume that the 6 households can constitute a random sample of American households. Round to at least 3 decimal places. So those that are on, if you're watching the video or if you're live on the call, try writing out the things that you know on your own for yourself. If you have your Alex pulled up or your Desmos calculator, I recommend that so that you can kind of check yourself. So I'm going to open up my Desmos graphing calculator. And binomial dist. And it automatically says I need to know trials and successes. So our trials are 6. And then this probability of success, I need to go back to the problem. And it said the probability of them watching and tuning in is 68%. So what I'm going to do here is I'm going to just split my screen. It kind of keeps things easier. If you don't know how to split your screen, I don't know how to do it in an Apple product, but if you have a laptop or computer other than an Apple, if you just go up and hover over this box, it will give you some choices for splitting your screen. And then it's nice that you can kind of just be in both. Um, so here I'm going to put 0.68. And then it says cumulative probability. So if you do the drop down, it's going to ask what you're looking for. So I'm not looking for an in between values. I'm not looking for the outer values. I'm not even looking for the left or the right because it's asking for exactly, I want all 6 of them. So that means I can just hit my zoom fit and I can just go over here and look at exactly 6 and click on that dot and see that it gives me the probability of 0.098867. And it said at least 3 decimal places. So I should be able to type that in and that should work. Let's check the answer here. Okay, that's correct. Let's try another in case it gives us something else. I think this is another exactly. Is everybody okay if I move on from the exactly? You can just give me a thumbs up in your Zoom if you're okay with that. Anybody want me to do another exactly? Okay, I'm gonna go to a harder one in advance. I think that's more of what we were looking for here. So the next one is in advance. It says the manufacturer of a fertilizer guarantees that with the aid of the fertilizer, 65% of plant seeds will germinate. Suppose the manufacturer is correct. If 8 seeds were planted with the fertilizer are randomly selected, what is the probability that at most 6 of them germinate? Carry your intermediate computations to at least 4 decimal places and then round your answer to 2 decimal places. Well, my intermediate, I don't really have to worry about if I'm using decimals because it's doing that for me. Thank you, Lord. Okay, so one thing I want to look at is it says at most. So first I'm going to go and I'm going to do this. So let's go to Desmos and let's just put in, and once you have this open in Desmos, you can just keep changing it for your situation. So we have 8 seeds that we planted, and then our probability of success is 65 this time. But this more thing, I have to at most, I think is what it said. There's my scrolly. At most right here. At most. Okay, so at most. Let's say we're struggling with that piece. So I'm going to go to my formula sheet right here. That's why I suggest printing it out so it's in front of you. Because if you look down here, you are going to need all of these pages to help you on your chapter 6 and your chapter 7 and 8 projects and helping you with understanding your ALEKS for the rest of the semester. So that's why I recommend printing it out. And I updated it. I hope it's useful. So at most, no, let's just go back here. At most. Okay. So back to the formula sheet. So it says, where is the at most? At most, right here. Less than or equal to. Okay, so at most means I can include 6, but I can include everything below 6. So that's why I have to say less than or equal to. So let's go back to the Desmos. The Desmos has a right. Well, I don't want greater than or equal to 5. I'm going to look at Michelle. You have your hand raised here in a minute, but it says less than or equal to. So we're going to put 6 there. Let's see what our question is. Are you able to share your screen?
Was my question.
I am. Oh, I'm not sharing. I had been. I thought I must have actually accidentally went away. Can you see it now?
I see your screen.
All I can see is you.
It says I'm sharing. Can everybody see now? Hmm. It says I'm sharing my screen.
I don't know
I've
if
been
it's
able to see the screen the whole time.
Hmm.
I have not, Sarah. I've been able to see you the whole time, but nothing else.
Hmm, that is weird. Okay. Okay, so this was our at most. And so that's why we're doing a less than or equal to. And so what it's doing, the great thing about Desmos is see, you can see what's being included and what's not. So that means 6, if you click on it, that's an included dot and all the ones below it, and 7 and 8 are not. So our correct answer should be 0.831. So I'm going to go here and put in 0.831. I'm going to make this big for a minute so that we can check it here. And we got a correct answer. Shall we do one more?
Yes, please.
This is a good one because it's a little bit different. So a multiple choice test consists of 8 questions. Cool. N is 8 again. Each has an answer of A, B, C, and D, and only one of the choices is correct. If a student randomly guesses on each question, what is the probability that he guesses at least 3 of them correct? So this is great because it's an at least, so it's a little bit different setup. And we don't see a percentage, right? We don't see a probability. But because there are 4 choices, A, B, C, or D on this multiple choice, that means that 1 out of the 4 of them is correct. So that means our likelihood of correct probability should be 25%. So let's go ahead and go back to Desmos for a minute, and we can leave that at 8 and then change that to 25%. And this is a greater than situation. It says at least 3 of them. So it's a right situation, and we want at least 3. So that means we're including 3. If you look at the wording, at least 3 is included. And I'm just going to make this big so everybody can see here that 3 is included and all the red dots beyond 3 are included. So our total probability is 0.321. So let's go back there and give that answer 0.321. Now I would like to get to one. That's another at most. Oops. Try another. Try another. I was trying to get one that was a little bit trickier, because strictly graded, greater than or less than. It's not giving me the, oh, right, here's a good one. Okay, let's try this one. A multiple choice test consists of 10 questions. Okay, again, multiple choice. There's 1, 2, A, B, C, D, and E. So there's 5. So that means if we go over here, that 1 of the 5 is correct. So that means my probability of success is 0.2 or 20%. So we can change that up here. And, oops, no, let's do this. And then it says there were 10 questions. So that's going to be 10. And it says, if a student randomly guesses on each question, what is the probability that she gets more than 2 of them? So more than 2 of them in this case means that 2 is not included, right? Only 3 or more. And because my options in Desmos are only greater than or equal to, I have to do the 3 or more. It happens to be, I already did that from the last one. So that means 0, 1, and 2 are not included here. But 3 is included because it said more than 2. And so that should be 0.322. And we are correct. So I think that hits all of the 3 types that will be presenting an issue. Is everybody okay if we move on from here? A question came up asking how I disperse the questions, and there is not one particular lesson that weighs heavily more than others. If you do the review should over prepare you for the midterm because there's more questions on the review than there are on the midterm. And I think I allow you to take the midterm a couple times, just like the quizzes you can take twice. If you haven't already noticed that, you can, I think you can do the review 3 times. Anybody else have any particular questions? Michelle's looking at chapter 3 where she had issues. Some other things while we're waiting for Michelle to figure that out. I just want to address how we type in data in, because chapters 7 and 8, you're going to have to get data into Desmos and you're going to be using it. It's going to be more efficient to do it in Desmos because Alex, you can hold it. It doesn't let you like open up the calculator to like see the whole data set. I know you all know what I'm talking about because you've probably done it before. So you have to send your data. The easiest thing is probably to send your data to Alex calculator and then copy that and then paste it into Desmos. The problem is it doesn't paste it comma separated. It pastes it, I think, semicolon separated, which is weird. But if you name your list, always a capital, I always use L equals, and remember it's brackets in Desmos, it's not parentheses. So people will send me and say, oh, it doesn't like my data, something's wrong. Nope, it's just that. So make sure you're using brackets, and then commas. Make sure you're, showing me all your work. So in chapter 7, you're going to really go back to everything that you learned in chapter 3. You're going to have to show me the stats of L. So then when you're using a command in Desmos, that's when you use parentheses. It didn't like that, and it's because I have an extra comma. So now it likes that. I'm going to need that, and then you're going to need your mean. All your commands, these are going to help you in your midterm. Remember, if you have sample data, it's STDEV, not with a P. A P is for population data. So make sure that you know whether you've been given sample or population. Finding your upper and lower fences, that was something that folks struggled with. So finding your lower fence, it's always taking your Q1, so that would be 1.5, and subtracting, ironically, 1.5 times the difference of your Q1 and Q3. So 3.5 minus 1.5. So there is my lower fence on this case. If I wanted to look at the box plot of this and just get a picture of what's going on, which we love to do as statisticians, I'm going to go up here and delete this or turn this off for now. And then I'm going to turn this on. Okay, so this is just the random data I just put in there. But you can see that these lower bars here are not always your upper and lower fence. They are the last data point of which your data is inside. We don't have any outliers. I'm going to add an outlier here to my data set. Okay. And look at the here. Okay. Does not say that's an outlier. That's too funny. Let's do this. How is this not an outlier? Trying to put it with this to get it to. Well, that's not a good example. Did you find your question in chapter 3, Michelle?
More so about entering the standard deviations into Desmos, and it was chapter 3.2.
So population sample in that area, I think notation for
Yeah.
population mean sample. Was it the notation or let's do this one. Okay, send a calculator. Well, it's not going to let me. This is a perfect example. We're going to send it to calculator. Once you get to chapter 6 and 7, you guys are going to love it because they give you more things on the Alex calculator to where it'll have a button for the standard deviation that you can just press. You'll say send a calculator, and then you'll just hit S of your data and it will do it. It's just right now it's making you do the calculation. So they do open up some things in chapter 6 and beyond, which is nice. So right now I'm copying that data. So Control C for copy. I'm going to go to Desmos, which if you noticed, it had a comma separated there, but now it won't when I paste it here. Oops. What happened there? So copying that. Paste it. Okay, so now I just have to go through and make these commas for a large data set. That's a pain, but the nice thing in Alex, they don't usually give you large data sets. So let's go back to the problem here. Okay. No, don't need that calculator any longer. So the monthly salaries are in thousands. That's important to remember. So of a sample, 6 representatives. Okay, find the standard deviation of the sample. And so our standard deviation should be here. I've already put the data in and it calculated it and I did the sample. It's with a P would be if it's population. And it says it wants to round to 2 decimal places. Okay, so 2.19 should work. Check our answer here. Was there another one that? So this is where I would use the commands. I know that sometimes students don't want to practice the commands because they're like, oh, it's hard or I don't understand. But the more you practice them, you'll see that the commands in Desmos are much easier than trying to figure out those formulas in Alex. Let's go back. What other one? What other, let's see, there's another question here. I'm wondering if my issue is putting parentheses instead of, yeah. So use a bracket if when you're entering data into Desmos. So just like here in my list, use a bracket when you're entering your data and then parentheses when you're using commands. So that's probably what the issue was. Let's see, I just brought one up. I wasn't sure if I really want to see this one. 3 distributions labeled A, B, and C are represented below by the histograms. Each is symmetric and it's made of 10 measurements without performing any calculations. Order their respective standard deviations. So we want to know which one is most spread out, which one is least spread out, and which one is in the middle. So a smaller standard deviation is going to be more of the data is around the center. So this one leads me to believe that it's the highest standard deviation because there are 3 data points way out here and 3 data points way out here. This one leads me to believe that is the smallest one on A because it's just like A, B, and C. They all have 2 at 6 and 2 at 8. So that's the same with all 3. And then the difference between A and B is A has 2 at 3, 2 at 11, where B has 2 at 3 and 2 at 11 on the inside. So that's where okay, so I'm changing my answer. So B has 2 at 3 and 1 at 4. A has 2 at 3, but 1 at A at number 2, which is out here. And then it has 2 at 11, 1 at 12, which is more spread out. And this one, so from B to C, it has 3 at 3 and 3 at 11, whereas B has 2 at 3, but 1 at 4, which is closer to the center, and then 1 at 10, which is closer to the center. So I'm thinking that B is the smallest. At first glance, I can make mistakes as well. And then actually, I would say C is the middle because it had 3 at 3, where A has 1 at 2, so that's further away, and 1 at 12, which is further away. So I think it's B, C, and A. So it's definitely kind of looking at everything. Look at the things that are similar and look at the ones that are the furthest away. So the data points that are furthest away is going to cause your standard deviation to be larger. Any other questions?